So hello everyone, in the previous session, in the previous video, we have studied a data structure called as stack, and in that we have studied the concept of stack, some of the operations we'll perform, its implementation using three different methodologies, and some of the top questions which we do based on those particular concept data structure of stack. We have discussed some of the most important questions of stack. Now in this video what we are going to do is we are going to study another data structure, that is queue, which is quite opposite to the functionality, or you can say in just essence it is quite opposite to stack. Stack is a LIFO data structure. It means that the last element will come out first, whereas a queue is opposite to stack. It means that it follows a FIFO data structure, which means that first in and first out. It means that the element which goes in will come out first. And if you study stack in detail, you can see that whatever the operations we are performing on a particular stack is only with the topmost element, whereas in queue we have two terminologies. So first of all, let me show you the visualization of a queue. So a queue will kind of look like this. Let's say that we are adding elements 1, 2, 3, 4, 5, something like this. So the first front side of a particular queue is known as front. There are some terminologies which we need to understand in order to perform operations in a queue, right? And the last element, or the element which added at the last, is known as array, right? And here whatever the elements we are deleting, let's say that I'm deleting 1, 2, 3, something like that. So deletion will happen from this side. So delete or exiting, you can say exiting, will happen here, and entry will happen, it will come here. So if I want to add a new element, let's say that I'm adding 10, so my element in queue will come here. So this is how entry will happen. And if I want to delete a particular element, then I can only do with the front elements. So here if I want to delete all elements, then the output will be 1. First of all I will delete 1, after 2, after 3, after 4, 5, 6, something like that. So 1, 2, 3, 4, 5 and 10. So insertion will happen from the rear side and deletion will happen from the front side. Now let us talk about some of the real-time examples of a queue. So whenever you go for a movie theater, you stand out for ticket in order to particularly watch that movie. So what we do is we inherently create a queue at that point, and whoever the person goes first will take the ticket and he can go into the theater, whereas the last person who comes at last will go at the very last, right? So the first person who comes first will go in, and the last person who come last will come out at very last, right? So this is the working of a particular queue. Now as we did operations in particular stack, there are operations, right? Add operation in stack, we have 3 operations. Add is nothing but push, pop and peek. Similarly in queue we have these 3 operations. Let me show you. So these are the 3 different operations which we have when we talk about a particular queue. So we have 3 operations. First one is add operation, which is also known as enqueue, and the second operation is remove operation, and the third operation is peek operation. Now let us study in detail. And one more thing is that if you are implementing the code of a particular any of these 3 operations, then your code is considered to be efficient only if these 3 operations is happening in big of one time, that is constant time, right? Now let us understand how adding and deletion will happen in a particular queue. For that, let us consider a queue. First of all, let us consider our elements. Let's say I'm adding elements 1, 2, 3, 4. So initially my queue will be empty. It means that my front value and rear value will be -1, right? And when I add, let's say that I'm adding 1, so I will add 1 here, and this will become my front, and this same element will become a rear. And again if I wanna add a new element into my queue, then that element will come behind the previously added element. It means that, let me show you, that the rare value will get incremented. So I will add one and second element will get added like this, and this will become my friend and this particular element will become my rare. Now if I want to add 3, then 3 will come like this, 1 2 3, right? So this is my rare and this is my friend. Now if I want to add my last element, which is 4, then my queue will become something like this, 1 2 3 and 4. So this will become my rare, and the first element which get inserted will be my friend. Now if this is how adding operation will take place. Now if I want to remove a particular element in a particular queue, then deletion will happen like this. Let's say that this is my queue, right? 1 2 3 4, this is my queue. Now deletion will happen like this. So if I want to delete a particular element, then I can't delete any random element. I can only delete the element which is at the front. So this is my friend, right? So first of all, I will change the value of friend to this, and after that I will delete this particular element. So this is how deletion will happen. So this is how deletion will happen in a queue. And if I wanna see the element which is at the front, then that is known as peak operation. So for peak operation, let's say that this is my queue, 1 2 3 4, right? So for peak, I will return the element which is present at the front. So what is the front element? That is 1. So I will return 1 as my output. So this is how adding, deletion and peak operation will work. I hope you got it. Now let us talk about, along with the operations, how we can implement our queue, and what are the Java collection frameworks will be given in order to implement queue very easily. Before going to Java collection framework, let us talk about how we coders can implement a particular queue directly without using any frameworks. So to implement a particular queue, we can use these three methods, which is we can implement queue using arrays, we can implement using array list, and we can implement using stacks. So these are the 3 different methods which we generally use in order to implement our queue from scratch. I can say that we will study about how we can implement queues using a very easy concept called as Java collection framework. But before going to frameworks, I want to implement queue from the very scratch, a particular queue using these 3 terminologies: arrays, linked list, stack, right? Now if you recall stack, we implemented stack using these 3 different methods, which are arrays, array list and stack. Similarly, we can implement a particular queue using these 3 things, and let us study about how we can implement these 3 different methods in our code. First of all, let us go with arrays. So I already told you that arrays are in fixed size, and again these are the not that much preferred way, because the size is fixed. So if you wanna add n number of elements, then it can't be possible because the size is itself fixed, right? After it, the one more drawback if we wanna implement a queue using arrays is the removing will take big of n time. You have to remember this, that if you are implementing a queue, then removing of a particular element will take big of n time. We will see how it will take big of n, but yeah, and this is not that much particularly preferred way to implement a particular queue using arrays. Now let us talk about visually how an array can be implemented, or how a queue can be implemented using arrays. Now let us say that this is my array. We already know that deletion will take with the first element. So if I want to delete, let's say that 1 2 3 4 5. Now if I want to add a particular element, then what I can do, I can particularly add from this particular rare value, and I can increment the rare value, and I can add particular, let's say that here initially front value is 0. Front value is always 0 because the 0th index is my front, and rare value here, the rare value is 4. Rare value is 4, right? 0 1 2 3 4. Okay, now let us say that the size of my array is 5. it means that I can add one more element to my queue. Okay, so to add, let's say that I'm adding 90. So if I wanna add a particular element in my queue, then what I have to do, first of all, I have to increment the value of rare. So the value of rare is here 4. First of all, increment, do r++ such that my r value will become 5, and after that insert the whatever the element you wanna add into your queue. So I will add 90 here. So this is how adding will take place. First of all, I will increment, and after incrementing I will check whether my array is full or not. If it is full, then I will show to user that adding elements is not possible because the array or the queue is full, right? If there is space, then after incrementing at that particular index I will add my element, right? So adding element will take around big of 1 time, whereas deleting a particular element will take big of 1, because let us say that this is my friend, right? So after deleting this element, I have to move each and every element towards forward, right? So this moving element towards forward of my array will take big of n, because I have to traverse each and every element and put it forward, because when I delete my first element, I have to put the second element at first and the third element at second position. So this replacing elements for all the elements in our array will take big of n time. Now let us talk about how we can implement in our code. Let me say first of all, so I'm import java .util .star. After that I'm creating my class, public class java programming. In this, what I'm gonna do is, first of all, I will create a class, public class, static class. Let's say that I'm the class name is q, right? After that, in that, first of all, I'm creating a integer array, int, let me give arr. After that, I'm creating again int size. After that, I'm creating a constructor q of, let's say that I'm passing int n. So here what I will do is arr is equals to new int of size n, right? So I'm assigning the size of my array. After that, here I will give size is equals to n. After that, rare is equals to, you can see that initially my rare value is -1. Now after that, after creating constructor, I'm creating my add function. So for creating add function, what I'm gonna do is I'm gonna call public my add function. So public void add. In this I'm passing int data, some value. After that, in here, if my rare is equals to size -1, then basically system.out.print q is full. That's all, and return from the program. Return, right? Else what I will do is, first of all, I will increment the value of rare is equals to rare +1. Now after that, arr of rare is equals to data, and print system.out.print element is added in the queue, right? Here I can give data plus some space here. Okay, so this is how adding operation will take place. So what I did in the add operation, first of all, I have passed a parameter int data. After that, if rare value is equals to size -1, that is my rare value is equals to the length of my array, then first of all print q is empty. After that, return out from the program. If it is not full, then first of all increment I, and after that add the data value into my given array or given queue. Now let us talk about how we can perform the operation of deletion or remove operation. So in that, first of all, I am creating public int remove in this. First of all, I am calculating is empty. So if my q if is empty, that is if my rar is equals to minus 1 is empty function, I am calling my is empty function. Here let me write my is empty function, public boolean is empty, return, I will return rar is equals to minus 1. If it is minus 1, it means that no element is added in the queue. If it is true, then I will print system.out.print queue is empty. Queue is empty. After that, return minus 1. Return minus 1. That's all. Else what I can do is, first of all, I have to store the value of front. So int front is equals to ARR of 0, and after that I have to replace each and every element forward of my array. After deleting the first element, I have to replace or change the value of front. So after that I will run a loop for int I is equals to 0 and I should be less than rar, after that I plus plus. In this ARR of I is equals to ARR of I plus 1. I am changing or replacing the value. After that, what I will do is I will decrement the value of rar. Rar is equals to rar minus 1. After that, return front. That's all. Here I have to give return front. That's all. This is my remove function. So in remove function, first of all, I am checking whether my queue is empty or not. If it is empty, then print queue is empty, after that return minus 1. Else first of all, store the value of front. After storing, delete the front value and replace each and every element towards the like front value, or you can say towards the previous, you can say, let's say that this is my queue, right? So if I deleted the first element, then the second element will come at first position, third element will come at second position. So this replacement will happen by this loop. After performing this loop, I am decrementing the value of rar and returning the value of front, which I have stored in this particular variable. Now this is the remove operation. Now let us talk about peek operation. So peek operation is also very simple. So public int peek. So peek, in this, first of all, I will check if is empty is true. If it is empty, then what I'm gonna do is I'm gonna print system.out.print queue is empty. After that, return minus 1, right? Else what I'm gonna do is I'm gonna return first of all, I'm gonna return ARR of 0. That's all, 0th element I am returning. So this is my peek operation. So in the main program, let me come out of the class. Now I'm creating my main program, public static void main string args. In this, what I'm gonna do is, first of all, I'm gonna create my queue class queue. Let me give the queue name is queue is equals to new queue. Now I am passing the size as, let me give 4. So the size of my queue is 4. Now after that, I am gonna perform operations queue dot add, and I am adding 0. After that, let me add. So I have added 4 elements. So here 1. After that, I am adding 1 2 3 4. After that, 3. Now let me save and run. So if I run this program, then I will get added 0, added 1, added 2, added 3. Now let me save and run. So you can see that we have got output as 0 is added. After 1 is added, 2 is added, 3 is added. Now if I perform remove operation, then let me see what output will get. I have performed my remove operation. Now whatever the output returned by the function, I am printing that. So here let me print. Yeah, now let me run. So you can see that I have deleted the top element. Now if I perform peek operation, then my output will be system.out.print. Let me see peak here. So if I remove the 0th element, then the front element will be 1, right? So let me see. Yeah, you can see that after adding, I have deleted the 0th element, and the top element, or you can say the front element, is 1, now 1. Okay, so this is how we are going to perform all these 3 operations in a particular queue using arrays. Now let us talk about how we can implement a particular queue using linked list. So up to now we have studied how we can implement queue using arrays, and we already know that there are 3 different approaches that we generally follow in order to implement a queue. Those 3 approaches are: first one using arrays, second one using linked list, and third one is using stack. Right now we have seen how to implement a queue using arrays, and we have seen some of the operations of it. Now what we're gonna do is we are going to see how we can implement a queue using linked list. Okay, so for that, let us consider a linked list. Let us consider that this is my linked list. So 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to null. Now we have 3 main operations, right? We have enqueue operation, which is nothing but adding elements, and the second one is removing elements, and the fourth one is peak. Third one is peak, or you can say front element, just seeing what is the front or the you can say first element on a queue, right? So these are the 3 main operations which we generally perform. Now let us talk about how we can perform these operations in a given linked list. So for that, first of all, let us talk about add operation. So we know that the queue follows a FIFO approach. Queue is a FIFO data structure. It means that the first element will come out first. It means that, let's say that we are adding elements 1, 2, 3. Now if I wanna add a new element into my queue, let's say that I'm adding 9. So my new element will come at last. So if we study the structure of a linked list, then we know that the terminologies which are involved in a linked list are the first element, we call the first element as head, and the last element we call it as a tail of my linked list. Now suppose if I wanna add 9 into my linked list, then the new linked list will look like this. So 1, 2, 3, and 3 will point to 9, and 9 will point to null. So this is how adding operation will take place. So first of all, you can see that first of all we have to reach the tail first. After reaching, then we can change the next referral variable of 3 to 9, and 9 will point to null. So my new tail will become 9, and head will remain the same. So in adding operation, if I specifically talk about add operation, in add operation, while using linked list for a particular queue, the only change is tail value will get changed if we are adding elements in our queue, if we are implementing our queue using linked list. Okay, so the adding operation is a 3-step process in a linked list. That is, first one is I will run a loop, and I will run a loop until I get my tail. And when I get my tail, what I will do is I will point the tail dot next is equals to my new element, or let's say that in this case new node. So I will point to tail dot next to my new node. After that, the third step will be new node dot next. New node dot next will point to null, and after that my tail value will become my new node. So this is the 3-step process. Now in this adding operation, while if we are implementing queue using linked list, then adding operation will generally take up to big of n time, because we are iterating through each and every node in my linked list, and after iterating through each and every node, I am changing the value of tail. I am performing these 2 operations, right? So first of all, this loop will take big of n time, or you can say the complexity of this loop will be big of n. Now let us talk about the removal operation. So if I wanna remove a particular element in a queue, then what is the fashion? I will let's say that this is my queue, right? Let's say that this is my queue, and if I want to delete the element, then I will delete element which is at the front, and in a particular linked list, the front element is nothing but my head. So if I change the head value, let's say that this is my initial head. Now after deleting, if I just change the head value, then the removal operation will get performed easily. So this is a single step process, that is head is equals to head dot next. That's all. So what I am doing is I am just basically changing the value of head, and this 2 will become my new head, and this will get automatically deleted by my Java garbage collector, right? So this is a constant time. So this will take constant time. And similarly, if I want to perform peak operation, or you can call it as front operation, then in this simply what I will do is I will just print head dot data. That's all. So these are the 3 different operations which we generally perform in our linked list. Now first of all, I'm gonna import all the Java collection package. So java.util.star, after that public class Java programming. Here I need to give util.star. Okay, Java programming. In this, first of all, I am gonna create my class, static class q. In this, what I'm gonna do is QUE. Okay, q. In this, first of all, I'm gonna create a linked list of, let's say that I'm creating an integer type linked list. So linked list ll is equals to new linked list. After it, what I'm gonna do is I'm gonna perform add operation. So I'm gonna create a function public void add. So in this, I'm gonna pass my data int data, and if my linked list is empty, that is ll.size is equals to 0, then what I'm gonna do is I'm gonna add ll.add that particular given data into my linked list, right? After it, I will print system.out.print data plus is added into my linked list or into my queue. We are implementing queue using a linked list, right? So the data is added into my queue. Okay, if there are some elements present in my linked list, then what I have to do, I have to add towards the end of my tail, right? And we need to point the tail dot next to null. So instead of like we coders directly like pointing tail dot next to something, and instead of iterating, what I'm gonna do is I'm gonna directly insert my element at a particular index. So this is my data. So at the last index I have to add, right? So what I can do is I can use the size variable. So ll.size -1. So in this particular index, what I'm gonna add is I'm gonna add data. So this is the basic adding operation, and after that I'm gonna print system.out.print data is added in the queue. So what I did that instead of putting a loop to iterate towards the end of my tail, what I did is I just added using this function ll.add. I have added the element at the last of my linked list, right? After that, let us talk about remove operation. Now for remove operation, I'm going to create a function public void remove. In this, if my queue is empty, that is ll dot is empty, then what I'm gonna print is system.out.print queue is empty and return from my program. Return. Else if there are some elements, then what I'm gonna do is ll.remove 0th element. So I'm gonna remove the front value, right? So I'm gonna remove the first front value, right? After that, that's all. And along with that, what I can also print the removed element, right? So here I'm gonna print system.out.print yep, that's all. So whatever the element I have removed from the first index, that is 0th index, first element 0th index, I am gonna print it. That's all. So here I can give here removed element is and some space plus some this. So this is the removal operation. Now let us talk about front operation or peek operation. Peek. So here I'm gonna implement public void front. In this, if my queue is empty, that is ll dot is empty, then what I'm gonna print is system dot out dot print queue is empty. Queue is empty and return from a program. Return. Else print system dot out dot print ll dot get 0th element. That's all. So this is how I'm gonna perform, and after that in the main program, I'm gonna create my function public static void main string args, and I'm gonna create my queue class. So queue is equals to new queue. After that I'm gonna add elements queue dot add. I'm gonna add 1. After that queue dot add 2, queue dot add 3. Here I need to give instead of a queue. Okay, now let me save this, and if I run this, then it will show that 1 is added, 2 is added in my queue, and 3 is added. Now let me save and run. So you can see that 1 is added into my queue, 2 is added in the queue, and 3 is added in the queue. This is how we are going to implement queue using linked list. So now we are going to see how we can implement a queue using stack. So to implement a queue using stack, we need 2 stacks, and in this method there are 2 different approaches. The first approach is using push approach, and the second approach is using pop approach. In this session, what we are going to do is we are going to see how we can implement a queue using 2 stacks with push approach. I want you guys to go and Google it or try to find out how we can implement a queue using 2 stacks with pop approach, right, with the deleting approach. Now in this, what is the push approach is that we will take 2 stacks. We will take 2 stacks. Let us consider this is my stack 1 and this is my stack 2. Now let us consider a sample queue which I'm gonna create. I want, right? So let us consider this is my sample queue which I want to create. Right, this is my sample queue, and this is what I want to create, right? This sort of queue I want to create using these 2 stacks, right? Now let us talk about 3 different operations, right? We have add operation, we have remove, and we have peek. So first of all, adding in a queue is using stack is that first of all I will check if my S1 is empty. If S1 is empty, then first of all add the whatever the element you wanna add into the stack. So what I will do is, let's say that these are the elements I wanna add 1, 2, 3, 4. So first of all I will take my first element and I will check whether the stack 1 is empty or not. Here you can see that stack 1 is empty. So if stack 1 is empty, then directly add that element into my stack. So I will add 1 into my stack. Now after that I will go to 2. Here you can see that the stack is not empty. So if the stack 1 is not empty, then what we have to do is, first of all, take all the whatever the elements we have from stack 1 to S2. So I will take 1 to S2. After that I will add 2, right? So I will transfer the first element to my stack 2. After that I will push this 2 value into my stack. So I will push 2. After that I will take back this to my 1. Right, after that here I need to add 3, right? So what I will do is I will push I will send these 2 elements to here. So 2 and 1 will come here, right? 1 and 2 will come here. After that I will add 3. Like this order I will follow in add operation. So what I will do is, first of all I will check if my stack is empty, then add that element into my stack 1. Else what I will do is, first of all I will transfer whatever the elements present in my stack 1 to stack 2. After that I will add the element into my stack. After that, whatever the elements present in my S2, I will send that to S1. So this is the approach of my add operation, right? Now for remove, what I will do is I will just remove whatever the top element. So s1 dot pop, I will perform this operation on s1, so this will do my pop operation. And for peak I will just use this operation s1 dot peak. So these are the three operations which we can perform if we want to implement a queue using two stacks. Now let us code this thing, and by coding we will understand it. So first of all, I am gonna import java.util.star. After that, I am gonna create public class java programming. So now I am gonna create a static class, queue. In this I'm gonna create two stacks. So stack of integer s1 is equals to new stack. After stack of integer s2 is equals to new stack. Now after it, I'm gonna create a function public boolean for checking whether the stack is empty or not. So is empty. Here I'm gonna return s1 dot is empty. I'm checking whether my s1 is empty or not, right? After that, I'm gonna perform add operation. So public void add. In this I'm gonna pass some data into data. So what I'm gonna do is, first of all, this is my step 1. While s1 is not empty, then what I will do is s2 dot push s1 dot pop. So what I will do is, in the first step, what I did is, first of all, whether I am checking whether the s1 stack is empty or not. If it is not empty, then I am gonna pop that element and I am gonna add whatever the elements present in s1 to s2. Now after that, I will push data again from s2 to s1. So while s2 dot is empty, s1 dot push s2 dot pop. Right, after running loop, I will print system dot out dot print data is added in the queue. Yeah, so this is the code for adding elements in my stack. So what I am doing is, first of all, I am checking whether the s1 is empty or not. If it is not empty, then whatever the elements present in my stack, I am gonna take it and push it towards s2 stack. And after that, after pushing all the elements, after removing all the elements from the s1 stack, I am gonna insert whatever the data given to my given by my user, right? So I am gonna insert that into my s1 stack, and after inserting whatever the elements present in the s2 stack, I am gonna take it and push it in my s1 stack. So this will become my add operation. Now let us talk about remove operation. So first of all, I will create public int remove. If is empty is true, then system dot out queue is empty. After return -1, return -1, return s1 dot pop. That's all. Now let us perform peak operation, or you can call it as front operation. So to perform front operation, I am going to create a function public int peak. In this, if my stack is empty, which my queue is empty, is true, then what I'm going to do is, first of all, I will print system dot out dot print queue is empty, and after that I'm going to return -1. Else I'm going to return system dot out return s1 dot peak. That's all. So this is how I'm gonna perform these three different operations. Now in the main, I'm gonna create my main function, public static void main, and in the main function string args Now I'm gonna implement my queue. Queue is equals to new queue. Right, after it I'm gonna add queue dot add 0, after queue dot add 1, queue dot add 2. Now let me save, and if I run this program, then it should show that 1 is added, 2 is added, something like that. So it is showing that 1 is added in the queue, 2 is added, 3 is added. So let me revise you a little bit that what we did in the add function. So first of all, I have created 2 stacks, and in the first stack I have added the element initial element into my stack if the stack is empty. If S1 is not empty, then what I did is I removed all the elements from S1 and transferred to my S2 stack. And after removing all the elements in my S1 stack, I have added the given element, given data. And after adding, I have again retransferred all the elements from S2 to S1. So this is how adding will take place. Now in the removal, what I did is I have just popped out the topmost element of my S1 stack. And in peek operation, what I did is I have just sended or returned the topmost element which is present in my S1 stack. So these are the 3 different operations which we performed using 2 stacks, right? Now let us talk about how we can implement queue using Java collection framework. So I already told you that Java collection framework gives us some inbuilt classes and interfaces by which we can easily implement any data structure, whether it may be queue, stack, array list, linked list. We can easily implement all these data structures in just one line. So what I am gonna do is, first of all, I will import public import java.util.star. After that, I'm gonna create my class, public class Java programming. In this, I will create my function public static void main string args. After, to implement queue, you have to understand one thing here, that we will discuss the overall picture of Java framework in the next slides, but for now you have to understand that queue is an interface, whereas a stack is a class. So we can directly create the objects of class, but we can't directly create the objects of interface. So what we will do is we will implement queue using other classes like linked list, by using array dq. There is a class called as array dq. We will use that to implement queues. So queue is a interface, not a class, so we can't directly create the objects of queue. So what I'm gonna do is I'm gonna write queue of integer. Let's say that I'm giving queue name as a is equals to new array dq, or I can give a new linked list also. So this is how I'm gonna create a queue using Java collection framework. Now how I can add elements? So I can add a.add, and I'm gonna add some values like after a.add 1, after a.add 2, something like this. So this is how I'm gonna add elements into my queue. Now if I wanna print overall structure of my queue, then what I will do is I will just print. Here I need to give another bracket. Okay. Now if I wanna print the old queue, then I will just print system.out.print a. That's all. Now let me save and run. So you can see that these are my added elements. Now if I wanna remove an element, then what I will do is a.remove. That's all. Now after that, again I will print a value. Let me save again and run. Here after printing I need to print, after removing I need to print a value. Let me save and run this. So you can see that initially I have added 0, 1, 2. After that I have removed the front element, and after removing I have printed again the same queue. So this is how adding, removal and front element will take place, and by just writing this one line we can implement queue. And if we are in competitive programs or we are giving some interviews and we don't have enough time, then we can just directly write this line and we can go with our queue creation, right? But if the interviewer or in a particular question you have been asked to implement queue using arrays or array list or linked list or stacks, then we have already discussed the approach. In that particular scenario, you have to implement on your own. You can't use Java collection framework at that point. But anyways, if you are in competitive coding or anything like that, then you have to use this approach. Just write one line and that's all, you're sorted.